Hello everyone, for this tutorial video, I like to explain how you can use integrals to check if certain series have finite values called convergent or infinite values called divergent. If we first start with an infinite sum where the first term n equals 1 of a subscript n, and we draw a curve starting at 1 and going to the infinite n, and then use rectangles that underestimate the area, we see, with some careful trickery, that if we use I equals 2 rather than 1 as our first start point, it must be less than the integral that starts at 1 and ends at the arbitrary value n, and then take n approaches infinity. We can see because any finite value is less than infinity by definition, any integral with a finite value of n as the upper limit must be less than an integral with infinity as the upper limit. This in turn implies that a sum that starts at I equals 2 rather than 1 must be less than this infinite integral. We remember that we started our proof with the assumption that I equals 1 rather than 2, however, so we have to figure out how to relate this to the start point of 1, which is actually somewhat easy if you see that you can simply add the first term to the rest of the sum, which means to keep everything in the inequality the same, we would add the first term to everything and not simply the left-hand side. And we also see, because all the terms in the series are positive, this means that the sum up to a certain index must be less than or equal to the sum of the next index, or index plus 1. In conclusion, we have seen that if the integral approaches a finite value, i.e. is convergent, the sum must be convergent as well. However, if we have an overestimation of the integral instead, we would see that the sum would be greater than the integral. So, by similar logic, if the integral is divergent, then any sum greater than this integral must also be divergent. However, even though these tests are convenient to know, they will not work if we cannot compute the integral. So we will see other test methods starting with the next video, where we discuss the limit comparison test, aka the comparison to a series we know the definite value of, or the definite value of its limit. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.